Welcome to Undersea Adventure. Move the mouse and click on the controls to begin your undersea. Visit the kelp, coral, and open ocean rooms for clues. Then click on the shark to start the 3D treasure hunt. Press Escape to return to the main menu.
Hi, my name is Splash. I'm a manatee. Well, I used to be a boyatee, but then I grew up. That's a little joke there. Swim around, check out the ambient aquatic environment. And if you're in a gaming mood, click on the shark behind you. Oh, don't worry, he won't bite. He just ate a boatload of tourists. Ew.
Oh, come on in. Have some kelp with us. I just love the way it slithers down your throat. It's so slimy.
Wow, wasn't that fun? Remember, click on that nasty old shark to start the game.
Well, aloha hoi, come on into the ocean, eh?
Surfing USA!
Ow, oh, ouch! Oh, hi there. Hey, welcome to the coral area. Be careful, it's very sharp. Ouch!
Wow, wasn't that fun? Remember, click on that nasty old shark to start the game. Come on, swim through and find the sunken treasure, but hurry or your oxygen will run out. You're doing great. Keep on swimming, but be sure to avoid the predators.
Oh, I can't believe it! An undersea expert! Ow, it's been, I forget how many years! Oh, why, you are the smartest kid I have ever met! The smartest kid who ever lived in the history of the universe!
You're doing great. Keep on swimming, but be sure to avoid the predators.
Oh, I can't believe
See some action video in the Undersea movie theater. Manta means blanket in Spanish, and the manta ray's fins certainly look like a large blanket. They are strong enough so that the manta ray can use them to leap out of Small fish will sometimes follow rays, hoping to pick up scraps of food that the ray might leave behind when it is Of all the Earth's living reptiles, turtles are the most in danger of becoming extinct. That is why many countries have passed laws protecting them and their nesting. Turtles live most of their lives in the sea and only go ashore to make a nest and lay their eggs. They have powerful flippers which enable them to swim very quickly, but they are very clumsy walking on the ground. Today, turtles are in danger of becoming extinct. An octopus has no bones or shell. Thus, it can reshape its body and squeeze into tiny holes and cracks between rocks. It can also change its color to blend into its surroundings. Moray eels come out of their hiding places in the rocks to hunt for food. Some people believe that they are poisonous, but that isn't true. However, when threatened, they can use their sharp fangs to inflict dangerous. Sponges feed by filtering water through the pores and canals which pierce their bodies. They are extremely efficient and will extract almost every particle from the water, even creatures as small as bacteria. Stingrays get their name from the sharp, poisonous barb in their tails. They use it as both an offensive and defensive weapon. They normally avoid contact with humans, but will sting an unsuspecting swimmer if stepped on by accident. There are many kinds of reef environments. Some are in shallow, sunny water. Others are deeper and look more like the coloring of this grouper helps it hide in the reef. The grouper can lurk in the shadows, and small fish swimming by won't notice it until they are sucked into the grouper's large. Tropical reefs are extremely rich in marine life. A single reef can be the home for thousands of different types of animals and plants. All the different creatures depend on each other, and if the presence of humans or pollution reduces the number of just one of those creatures, all the others will be. Fish which live on the reef are often brightly colored so that they blend in with the bright colors of anemones and
Triggerfish get their name from the 3 rays on their dorsal fins. These rays can be locked into an upright position so that the fish can wedge itself into a crevice when
a parrotfish's front teeth are fused together, forming a beak. It uses the beak to break off pieces of coral. It grinds up the limestone skeletons to get to the soft animals inside. Porcupine fish have armor plates made up of strong, sharp spines. When frightened, they fill themselves up with water so that they get bigger and the spines stick out. If they are removed from the ocean, they fill up with air until they are placed back into the Jacks like this have a slender, streamlined body which makes them very strong swimmers. Butterfly fish have a very compressed body that makes it easy for them to swim between the twisting branches of coral. Some varieties are easily approached by divers and do well in aquariums. Aren't you glad your school isn't this crowded? These fish like the crowd because there is safety in
Groupers and basses are well known for their large mouths, which rapidly expand and suck in unsuspecting prey.
When a ship sinks, animals will start to make a home inside of it. Coral and sponges will attach themselves to the bulkheads of the ship, while other creatures will find cracks and holes to live in. Soon the ship will look a lot like a natural. Divers must be very careful when exploring a shipwreck. They never know what might be hiding behind a wall or door. There might be a hungry shark. Rays and sharks can look very scary, but even these animals can be gentle enough to eat out of a diver's hand. Even though they are very large, they will not hurt divers except to defend them. Humpback whales can weigh up to 50 tons. It takes great strength to hurl their bodies out of the water. This behavior is called Because humpback whales are mammals and not fish, they must frequently return to the ocean's surface. Dolphins are strong enough to jump out of the water and still keep up with a very fast. In their natural environment, dolphins like to jump out of the water while they swim. This behavior makes it easy to train them to perform for people at marine parks. Dolphins are social animals and like to swim in family groups. That way, the stronger dolphins can protect the other dolphins who are too young or sick to protect themselves. Orcas, or killer whales, can swim at speeds of up to 30 miles per hour. They are also excellent divers and can dive to depths of more than 3,000 feet. To dive so deep, they can hold their breath for up to 20 minutes. Orcas, or killer whales, are really large dolphins. Like dolphins, they live and hunt together in packs. However, they don't deserve the name killer. In captivity, orcas can be very friendly to humans. Narwhals are normally found only in Arctic waters, so photographs of them are rare. In ancient times, they were thought to be magical creatures because the narwhal's horn reminds people of unicorns.
Seals have a body structure similar to that of dogs and cats. However, they are well adapted to an aquatic life, with flippers and a streamlined body.
While looking at this seal, notice that it has no visible ears. That's one way to tell the difference between seals and sea lions. Sea lions have ears which stick out far from their Elephant seals are called that because the males have a large fleshy nose that resembles an elephant's. The males are up to 3 times as large as the females and are very territorial. They frequently fight each other to impress the Sea otters spend most of their lives in the ocean. They even sleep in the water, floating on their backs. They tangle themselves in kelp to keep from drifting out to sea while jellyfish do not pursue their food. Instead, they wait for a fish to swim by and get tangled in their tentacles. The tentacles contain cells which inject a stinging poison which keeps the fish from swimming. Most sea anemones are permanently attached to a rock or other surface, but some species can actually jump and swim a short distance when it Sea anemones use their tentacles to sting and capture fish to eat. Some animals, like these clownfish, become immune to the stings. Then they live inside the anemone's tentacles where they are safe from larger Some scientists consider the shark to be the ultimate predator. It is perfectly designed for hunting in its environment. A swell shark gets its name from the behavior it displays when frightened. If attacked, it will swim into a crevice and swallow water until it swells up. That way it is jammed in the hole and the attacker cannot. Kids, don't try this at home. These divers are trained professionals. When divers want to study or photograph sharks, they must get inside big metal cages where they are safe from the shark's bite. They use pieces of meat or fish to attract the sharks. This way, the divers get great pictures while the shark gets a free. Polar bears are one of the most dangerous predators in the Arctic. They are excellent swimmers and will dive under the ice to chase their In the entire world, there are only a handful of divers who have the special equipment and training required to tackle the dangers of diving under polar ice. Mammals which live under the ice, like these Arctic seals, have special layers of fat under their skin to keep them warm. They will stay in the water most of the time to avoid the extremely cold Arctic air. Because of its size and large tusks, a walrus can be dangerous to people when angered or frightened. It normally uses its tusks to dig for food, such as clams from the mud on the ocean. Study the marine animals that interest you most in the Undersea Reference Set.
Sea otters, primitive tool.
South Pacific, islands galore. The Pacific Islands are home. Blacktip reef shark, short and feisty. The blacktip shark may not be large, but it is fast and aggressive. Found in the warm waters of the Atlantic and Pacific Oceans, the blacktip shark grows to a length of 6 feet and can be easily recognized by the clear black markings on its dorsal and ventral fins. The blacktip shark is a powerful swimmer capable of moving quite rapidly when it attacks a favorite prey, such as a stingray, school of sardines, or butterfish. Blacktips are often seen leaping completely out of the water, though no one is quite sure why they do this. Blacktip sharks are most common in the Gulf of Mexico and the Caribbean, where sports fishermen like to try to catch them with a hook and reel. Like all other sharks, blacktips have a skeleton made of cartilage and not bone. Cartilage is lighter than bone and allows sharks to swim farther while expending less energy. Sharks, such as the blacktip shark, are not built for long periods of fast swimming. Most sharks' bodies are best suited to long-distance cruising, during which very little of their energy is used up. The moment food or danger is nearby, though, a shark like the blacktip is capable of high speeds of close to 20 miles an hour.
Arabian Seas, the oil route. The waters of the Arabian Peninsula and neighboring countries form a distinctive subregion of the Indian Ocean. This area Arctic Ocean, small and cold. The Arctic Ocean is the smallest of the world's oceans. Its average depth is about 3,300 feet, though in places it does reach about 6 times this. There are 4 major basins separated by 3 oceanic ridges, of which the largest, the Lomonosov Ridge, extends for 1,100 miles. Water enters and leaves the Arctic Ocean through the gap between Svalbard and Greenland. A deep water current near Svalbard accounts for nearly 80% of incoming water, which is balanced by a less saline outflow on the surface. 2% of the water leaving the ocean is in the form of icebergs. The ocean itself is covered by a layer of sea ice, which in later winter extends to up to 6 million square miles. In summer, it shrinks to about half this size. Many marine animals in the Arctic migrate as the sea ice advances and retreats with the seasons. Most live near the edge of the ice, which provides a hauling out area for such animals as polar bears, seals, and walruses. Numerous species are found all around the North Pole, but are often divided into several distinct stocks or subspecies. Many bird species are seasonal and also undergo long migrations. Human populations have existed around the Arctic Ocean for thousands of years. A distinction is often made between the Nordic populations, whose lifestyle is based on the herding of reindeer, and the North American, Siberian, and Greenland populations, who subsist by hunting marine animals. Mammals dominate the Arctic marine ecosystem. They include seals, walruses, whales, and polar bears. Although there is little wildlife at the center of the Arctic basin, around the edge, where the sea ice advances and retreats with the seasons, and winds and currents bring up nutrients from the depths, an abundance of marine animals and plants flourishes during the summer. Polynyas, which are small areas of open water in the ice, are used by birds and mammals as feeding grounds, as well as by peoples of the Arctic. These areas only open up in warm weather. The animals of the Arctic are suited to the extreme climatic conditions by a number of physiological and behavioral adaptations. Physiological adaptations in mammals include the thick layer of insulating blubber, which acts as a food reserve in times of hardship, a high body mass, and a low surface area. The blubber is built up by seals and whales during their summer feeding period. Constant foraging when conditions are favorable and the rapid development of young are adaptations that help individuals to meet their high energy requirements. The excellent insulating qualities of feathers enable birds to survive and even spend the winter in the Arctic. However, a high proportion of the Arctic birds migrate southwards in the summer. Harp seal dances with seals. Did you know that harp seals can dance? During the mating season, the male harp seal will court the female harp seal by dancing up and down in the water next to her, keeping his body and head held in a vertical position. Harp seals can be found in the White Sea, on the east coast of Greenland, and on the northern coast of Newfoundland. Young harp seals are born with a white coat, which gradually changes into a dark brown pattern as they grow older. Baby harp seals feed on mysids and euphisids, while adults eat crustaceans as well as herring, squid, and polar cod. Harp seals follow a migratory pattern and move south in the winter and north in the summer as the ice begins to melt. Galapagos iguana, scary sea serpent. The giant iguanas of the Galapagos Islands are the only marine lizards other than marine crocodiles. They are big and black with large, warty masses of cells called tubercles on their heads and bodies. This makes them look much like the lava rock they usually bask on during the day. At night they go into crevices and caves higher on the shore to rest or sleep. As they are cold-blooded, their black skin helps them to take in the sun's rays and absorb warmth. Early explorers hunted iguanas for food and found them delicious. The iguanas seemed tame because they would not run into the cold seawater nearby. We now know that the iguanas must have the warmth of the sun to stay active. It is unhealthy for them to get cold for too long, so they are reluctant to enter the cold water when it is not necessary. These monster-like sea lizards are vegetarians. They feed on a brown seaweed called sargassum that grows on the underwater rocks, chewing it with their sharp teeth. These iguanas have flattened bodies and tails that they swing widely from side to side while swimming. Their arms and legs are pressed back along their sides. The only water for them to drink is seawater, but they have a handy salt gland in their noses that takes the extra salt out of their blood and produces drips of salty water that fall onto the rocks. The large female iguanas lay their eggs in caves near the shore, usually dug into sand or soil. Usually these burrows are within the territory of one dominant male who is the father.
Amberjack, strength in numbers. If you were a squid, an amberjack is one fish you wouldn't want to meet in a dark kelp bed. Amberjacks are fierce, powerful hunters that travel in giant schools and cruise the warm and temperate waters of the Atlantic in search of small fish and squid. Like the tuna and mackerel, amberjacks are well built for long-distance swimming. They have streamlined, muscular bodies, and their skin is covered by tiny, almost invisible scales that allow them to cruise through the water with little resistance. Amberjacks can grow to lengths of 6 feet or more and weigh as much as 120 pounds. Amberjacks are such determined hunters that they will often chase a school of small fish into a shallow lagoon just to get a meal. Young amberjacks look quite different from adults. Their bodies are thick rather than thin and covered with stripes. Even as young fish, amberjacks like to travel in enormous packs. Eventually, as amberjacks get older, they become less sociable and begin swimming in small groups of just a few fish. Arrow crab, hardly Cupid's arrow.
Arrow crabs are the daddy longlegs of the sea. They move slowly and deliberately as if in slow motion. This behavior, combined with their raggedy appearance, makes them very difficult to spot underwater. Their long legs are hollow tubes made up of tough chitin and filled with muscles down the center, just the opposite of humans, who have bones inside and muscles outside. These tubes of muscle are what you buy as crab legs in the supermarket. Crabs cannot exist out of water for more than a few minutes because their shells dry out very easily. During low tide, these crabs can be found under piles of moist seaweed, down in shady crevices, or in the remaining water of a tide pool. Crabs breathe by pumping water over the feathery gills on their bodies. Cockle, moving in leaps. There are many different cockle species on the European shores. It is easy to find their shells on the beach. This mollusk, which belongs to the genus Cardium, moves by leaping, supporting itself on its muscular foot. This foot shoots outside the valves and with a quick contraction causes the mollusk to be thrown upwards. It also uses this foot to bury itself in the mud or in the sand, where it spends most of its life. The cockle feeds on particles in suspension, which are part of the plankton, by filtering seawater through the cilia which cover their gills. In order to breed, both the male and female cockles expel their gametes into the water, where the spermatozoa fertilize the ova in a totally random process. This mollusk has a lot of enemies, among which is man, who harvests it by the millions. Sea anemone, meat-eating fly. Brown sponge, always eating. It may seem unlikely, but sponges are giant feeding machines. Sponges are constantly filtering water through their bodies to trap the microscopic animals and small pieces of organic matter that float in the water. Sponges with large openings at the top of their bodies are the best at filtering lots of seawater for food. If you gently put your hand over the top of a sponge, the flow of water feels like a spring welling up out of the ground. On some shallow reefs, you can even see the ocean's surface continually bubbling up because large sponges are pushing water up through their mouths. Sponges use the same filtering system to reproduce. The sponge's male cells release tiny swimming cells into the water. These cells are tadpole-shaped and have a long hair that waves on their back end. The cells get swept up in the water currents of another sponge and then fertilize the eggs that are embedded in its wall. At this stage, the egg cell divides into more cells and the resulting larva, covered with hair-like cilia, swims out to find a new home. Once the larva settles somewhere, it grows rapidly, sometimes living only a year or so. It's also possible for a sponge to produce small buds that turn into new sponge animals without sexual reproduction. In fact, people who fish for sponges to sell have known for some time that if you separate a living sponge into little pieces and attach these pieces to good spots on the sea bottom, each would develop into a new sponge in several months to a year. Oceans, climate, and weather.
The oceans have been referred to as the flywheel of the climate system, since like a flywheel they store energy in the form of heat when it is in plentiful supply during the day or summer, and release it to the atmosphere when sunshine is absent or in short supply at night or during the winter. But this analogy is inadequate because the oceans do not just act as a passive energy store, but also play an active role, with ocean currents moving thermal energy from the warmer tropical and subtropical regions to the higher latitudes. As warm ocean currents move toward the poles, they lose heat to the atmosphere, and the warm air, when carried by winds over neighboring land masses, warms the land at night or during the winter. Oceans, therefore, play a part in determining the climate of a specific region by reducing the extremes of temperature which would otherwise occur. Western Europe, for instance, has a much more mild climate than Eastern and Central Europe because of the heat from the Gulf Stream which moves into the atmosphere. The temperature differences between land and sea reflect the different rate at which they absorb and lose heat. The land surface heats up faster than the sea during the day, but loses heat faster during the night or in winter. This is because the upper layers of the ocean mix with those below, passing some of the heat gained during the day downwards, and so reducing the rate at which it is lost to the atmosphere. The temperature range of the entire ocean is therefore small, from about 28 degrees Fahrenheit, the freezing point of salt water, to 86 degrees Fahrenheit, although temperatures as high as 95 degrees Fahrenheit are found in some semi-enclosed seas. During the course of a day, ocean temperatures rarely vary by more than 1 degree, and usually no more than 18 degrees over a year. For comparison, the range of temperature experienced in the middle of a continent during a year can be as great as 144 degrees Fahrenheit, and deserts may be scorching during the day, but freezing at night.
Southern Ocean, the deep freeze. The Southern Ocean, the great unbroken expanse of sea linking the Pacific, Atlantic, and Indian Oceans, surrounds the unique continent of Antarctica. Its waters are ruled by powerful winds known as the Roaring Forties, the Furious Fifties, and the Shrieking Sixties, and its southern boundary is the ice cliffs and rocks of the Antarctic coast. The continent itself forms a hub around the South Pole. The shores of Antarctica are fringed by seas that are almost entirely ice-covered. In winter, 8 million square miles of sea have an ice crust. Even in summer, the coastal waters bear 1.2 million square miles of ice. This fluctuating fringe of ice can be seen as one boundary of the Antarctic, but most biologists prefer using a boundary known as the Antarctic Convergence Zone, an invisible frontier in the sea where cold surface waters meet warmed surface seas. The icy seas and frozen wastes of Antarctica present one of the most inhospitable environments on Earth. Yet the Southern Ocean is home to large numbers of seabirds, seals, and whales. This abundance of life depends on the biological productivity of the Southern Ocean. It is estimated that the Southern Oceans produce as much as 610 million tons of plant matter a year. Today, Antarctica contains over 90% of the Earth's ice. This represents about 70% of the planet's fresh water. The ice has accumulated to an average depth of about 6,500 feet over the continent as a whole, with more than 9,850 feet at many points above the low-lying rock floor of the continent. If all this ice melted, global sea levels would be raised by 200 feet. If the enormous weight of all this ice were removed, the surface of Antarctica could rise by 650 to 1,000 feet. Glaciers move slowly towards the sea and feed floating ice shelves. Known to pioneer explorers as ice barriers, the shelves are 657 to 984 feet thick and border the ocean over hundreds of miles. They can reach a depth underwater of between 490 to 820 feet. In winter, massive icebergs float among the sea ice. This creates a danger to shipping and mobile oil installations, which become trapped in the surface ice, unable to move out of the path of the icebergs. Only a narrow coastal fringe lies between the Antarctic ice cap and the sea. It is on this tiny area of land that most of the wildlife of the Antarctic lives and breeds, and where more than 70 scientific research stations have been set up. 2,000 to 3,000 tourists visit Antarctica each year, attracted by the scenery and abundant wildlife. Southern Ocean, the deep freeze. Arctic Ocean, small and cold. North Atlantic Basin, hot and cold.
The
West African Seas, population explosion.
Arabian Seas, the oil route. Mediterranean Sea, Europe's bathtub. Arctic Ocean, small and cold. North Atlantic Basin, hot and cold.
West African Seas, population explosion.
Arabian Seas, the oil route. Mediterranean Sea, Europe's bathtub. Mediterranean Sea, Europe's
Learn more about anatomy in the Marine Animal Lab.
Unlike many undersea hunters, the octopus relies almost entirely on its vision to find and catch prey. For this reason, the octopus's eye is highly developed and can probably see images nearly as well as a human eye can. Much of an octopus's brain is devoted to interpreting the many signals coming from the octopus's eyes. The octopus eyeball is flattened like a fish eye. To focus on an object, the lens of the eye moves rapidly back and forth. The eye of an octopus is also quite large, making it easy for the octopus to see well at night when it does most of its hunting. Octopuses have strong beak-like jaws that are so powerful they can crush the shells of very large crabs and lobsters. When an octopus captures its prey, it holds the animal in its mouth, then kills or paralyzes it with a poison that is secreted by the octopus's salivary glands. The octopus then injects into its prey's body a digestive enzyme that dissolves many of the animal's toughest body tissues. Once the animal's body is soft enough, the octopus sucks it into its mouth. Because the octopus dissolves most of its food outside of its body, it only needs a simple digestive system to absorb food into its bloodstream. A few hours after an octopus captures a crab or lobster, all that's left is an empty shell. Unlike many undersea hunters, contrary to what many people think, sharks have excellent eyesight. A shark's eye can see well during the day and also at night when many sharks feed. Sharks' eyes are built very much like human eyes, except that they are much thinner. The shark eye is composed of 3 chambers, an iris, a lens, and a retina. The size of the eye depends on what kind of shark it is and where it lives. Sharks that live in shallow waters where there's plenty of light have smaller eyes. They don't need to capture a lot of light in their eyes to see. Sharks that live in deeper waters, such as the mako shark, have much larger eyes to capture as much light as possible. To help see in very dark water, sharks also have a special reflective lens that is located at the back of their eyeball just behind the retina. This lens acts like a mirror, reflecting small amounts of light in the shark's eye many times over. It is believed that most sharks see in black and white, but it's possible that a few sharks also see in color. Ears are not found on the outside of sharks or on any other fishes. However, sharks still have very good hearing, particularly for low-frequency sounds like those made by struggling fish. The shark's ear consists of a small membrane of skin that is attached to a spot near the top of the head. This piece of skin moves every time there is a vibration in the water. Shark brain. For many years it was thought that sharks had simple primitive brains. Yet recently scientists have shown that many sharks have large capable brains, especially when compared to other vertebrates. Certain sharks have even demonstrated the ability to learn simple tasks. A shark's brain is the center of a complex system of nerves and senses. Millions of tiny electrical messages are transmitted to the brain from all over the shark's body. For instance, the shark's eyes are constantly sending information to the brain about what is visible to the shark. Electrical sensors in the shark's face transmit information about the electrical fields being created by other animals in the water. At the same time this is happening, the shark's brain is sending messages out to the different parts of the body, instructing them what to do. Brains differ greatly in size and complexity from one shark species to the next. Large, fast-moving sharks like the hammerhead and dusky shark have bigger brains, probably because they spend more time hunting and tracking prey. Slower, bottom-dwelling sharks, which find most of their food in one place, generally have smaller brains. Shark brains are divided into three large segments: a forebrain, a midbrain, and a hindbrain. Each of these segments is responsible for controlling a different part of the shark's bodily functions. A lobster's eye is located at the end of a long, movable stalk. The eye has a hard, curved surface that is made up of thousands of tiny lenses. Each of these lenses acts like a separate eye, detecting differences in light and dark. Some lobsters are capable of seeing certain colors, such as blue and green. Because the surface of a lobster's eye is so large, lobsters see movements over a very wide angle, like the wide-angle lens of a camera. Lobsters are probably able to make out the forms and shapes of different objects. Lobsters have simple brains. A lobster brain consists of a dense collection of nerves called a ganglion. The ganglion sits at the end of a long string of nerve fibers that connect the brain to the rest of the lobster's body. The combination of the brain and these long nerves is called the central nervous system. As with other animals, the lobster's central nervous system transmits tiny electrical messages between the different parts of the body and brain. For instance, nerves in the lobster's legs, eyes, and shell are constantly sending messages to the lobster's brain about its environment. The brain, in turn, sorts through these messages and reacts automatically to those messages requiring some kind of action. This type of response is called an instinct, because the lobster doesn't actually think about the action before doing it. If the lobster's eye sends a visual message to the brain, say that a fast-moving object is approaching, the lobster's brain might respond by sending an electrical message to the tail, telling the tail to close rapidly and propel the lobster to safety.
Sea lions have excellent vision, both under and above the water. Vision is important to find fish in the water and to see enemies, such as people, above water. People sometimes hunt sea lions since these aquatic mammals love fish, and fishermen are afraid they eat too many. Today, most sea lions are protected by laws. After diving 40 or 50 feet deep, the air in the sea lion's lungs becomes completely collapsed from the water pressure, and the sea lion relies entirely on oxygen stored in its blood and muscles. The sea lion also uses its lungs to cool off. By panting, it releases hot air that would otherwise build up in its body. The column is the support of the body and often has shells and bits of algae stuck to it. When the anemone is disturbed and the tentacles are folded into the top, the shells make the animal hard to see on the rocks. It also helps keep the anemone from drying out at low tide when the seawater is not covering the animal. The throat and stomach of an anemone serve to circulate water for breathing, removing wastes, and for digesting food when it is brought in by the tentacles. Any food that is not digested, like bones or shells, must be tossed back out through the mouth. Radioles are the main branches of the fan worm's fan. They hold the fan up into the water so it can collect particles from the sea. Little hair-like cilia constantly beat to draw the water through the fan. The mouth of the fan worm receives a stream of mucus filled with microscopic particles of food that have been gathered by the fan-shaped radioles and pinnules. Only the smallest particles are retained for food. Vision is generally poor in whales, but gray whales often stick their head up out of the water to look at the coastline. It is believed that they can recognize landmarks on shore like mountains and remember them to navigate the same route next year. Whales have large lungs to obtain oxygen from the air, but they exhale much of the air before diving. In a deep dive, the lungs are completely flattened and very little fresh oxygen is available to the whale. Instead, it uses the oxygen stored in the muscles and blood. The outsides of many sea stars are covered with small pincers on stalks. These protect the star by catching little animals trying to invade its skin. The stalks are concentrated around the large spines in the skin and also help keep the skin gills free of debris. The sea star has a large stomach that can be extended outside its body. After the star has pulled open a clam or mussel, it extends its stomach out of its mouth and between the clam shells to digest the unfortunate clam. A sea star will take hours to digest a clam dinner. The distinct rings in the shell represent years, like rings on a tree stump. This allows scientists to determine the age of the clam. In this case, the clam is 5 years old. Clams have a muscular foot that allows them to move about the bottom if they are not attached to a rock. Clams that live in sand and mud have a larger foot. It is pushed out the opening in the shell into the soft bottom. Water is pumped into the far end of the foot to expand it like a fleshy anchor. Then the clam pulls itself through the mud. By repeating this process, the clam can move deeper when danger threatens, or rebury itself if it is exposed. Next time you dig up a live clam at the beach, put it on a sandy or muddy bottom in calm water and watch it disappear. For a long time, it was thought that dolphins had poor eyesight. However, they can jump from the water and take small objects from a trainer. This certainly testifies to their good eyesight. In nature, it is more difficult for the dolphins to see because the water is usually not very clear. So in nature, the eyes are probably less important than the dolphins' famous sonar. Dolphins have relatively large, well-convoluted brains indicating a degree of intelligence. It is known that dolphins have signals and a rudimentary language. Much of the brain specialization may be related to the sonar capabilities, since bats, which also use sonar, also have relatively large brains. The large eyes can detect changes in the angle of the sun. This means sea turtles can migrate long distances over the open sea with only the sun and moon to guide them. Baby sea turtles climbing up through the sand right after hatching can recognize the horizon of the ocean even though they cannot see the water. The turtle's heart is four-chambered like those of mammals and birds, but the chambers are not completely separated. Blood returning from the lungs is partially mixed with blood returning from the body. When the turtle dives deeply or is sleeping on the sea floor, its lungs are flattened from the water pressure. But that does not stop the turtle because with its connected heart chambers, its blood can continue to circulate without going to the lungs. Jacks have large eyes and good vision to see small fish and squids in mid-water. Jacks often herd schools of small fish into tight quarters and then slash through them to wound and injure them. They then pick off the fish that stand out from the school because they are wounded or got separated from the protection of the school. The heart of a bony fish is just under the gills. Blood is pumped through the gills to pick up oxygen before going out to the body. After going through the body, the blood, now low in oxygen, returns to the heart to be pumped up through the gills again. The gills are finely divided into many very thin-walled filaments. They look red because they are filled with blood that is getting rid of waste, giving up carbon dioxide, and picking up oxygen. The gills are designed so that the flow of blood on the inside of the thin skin is in the opposite direction of the water flowing on the outside. This countercurrent flow makes it easier for substances to be exchanged between the water and blood. The gills are the lungs of the fishes, but they are also used for getting rid of waste products and balancing the salts in the blood.
Use your mouse or arrow keys to move around the 3D museum. Press Escape to return to the main menu. Follow a read-aloud story in the Ocean Tour.
During the tour, you can click on the speaker button to reread the text. Click on a word to have it pronounced.
Marine mammals.
Marine mammals act almost like fish. They swim underwater.
Dolphin. They have flippers and fins. Some even have smooth skin. But marine mammals are very different from fish. They have to breathe air. They have warm blood and they have live babies. They are also very smart. Marine mammals love to play, even when they are very big.
During the tour, you can click on the speaker button to reread the text. Click on a word to
Coral reefs. Coral reefs are beautiful places to visit. Many kinds of animals live there. Brightly colored fish swim together in schools. They spend their days looking for food. Sponges and anemones stay in one place. They eat the tiny animals that float by. When it's dark, an octopus will try to turn a crab into a midnight snack. You have to be careful in a coral reef. Sharks. I am a shark. Would you like to be my friend? I didn't think so. You're probably scared of me. But I'm really not as bad as you think. Some of us are tiny. Some of us are giant, like this whale shark. Most of us would never hurt a person. Still, you probably shouldn't try to cuddle us, especially not a great white shark.
During the tour, you can click on the speaker button to reread the text.
Odd couples. Animals in the ocean can make the strangest couples. Clownfish live in anemones for protection, and they don't get stung. Some shrimp love to clean a moray eel's teeth, and the moray eel lets them. Pilotfish will go wherever a shark goes, just to eat the scraps from a shark's meal. You would not exactly call them friends, but they do help each other out.
During the tour,
Can you find what part goes with what fish? I'll bet you can. Can you guess which animal this is a part of?
You're right. I'm a jellyfish, and that's my...
Can you guess which animal this is a part of?
You're right. I'm a coral, and that's...
Can you guess which animal this is a part of?
Oh, you're right. I'm a starfish, and that's...
Can you guess which animal this is a part of?
Oh, you're right. I'm an octopus, and that's my suction cup.
Can you guess which animal this is a part of?
Yes! Yes! You're right! I'm a porcupine fish, and that's my...
Can you guess which animal this is a part of?
You're right. I'm a sea anemone, and that's my...
Can you guess which animal this is a part of?
You're right. I'm a dolphin, and that's my dorsal.
Can you guess which animal this is a part of?
You're right. I'm a butterfly fish, and that's my...
You're doing great! Can you guess which animal this is a part of? Do you really know your undersea animals? Let's find out.
I'm an eagle ray. Can you find me? You sure know your stuff. I am an eagle ray. I live on reefs, but race out to sea to escape predators. Yikes! Is that fish? I'm a goose barnacle. Can you find me? Very good. I am a goose barnacle. I live attached to rocks, piers, and ships. I'm a hermit crab. Can you find me? Yeah, you're right. I'm a hermit crab. We live in old shells from other animals. How do you like mine, huh? I think it's pretty nice considering it was free. I hate...
I'm a penguin. Can you find me? Gosh, you're smart. I'm a penguin, and in my family, the males take care of the eggs. We'll go months without eating while protecting our young.
I'm a turtle. Can you find me? Oh, that's good. I'm a sea turtle. I flap my flippers to swim through water the same way birds use their wings to fly through the...
I'm a sea anemone. Can you find me? Oh, you know what they say, dear. If at first you don't succeed, try again. Oh, Oh, you're so right. I am a sea anemone. Keep your fingers away. I have a ring of poisonous tentacles. Ooh, that was close.
I'm a feather duster worm. Can you find me? Oh, absolutely right. I'm a feather duster worm. My feathery tentacles clean up all the food.
I'm a kelp plant. Can you find me? Righto, I am a kelp plant. Okay, so I may not look very exciting, but I can grow as much as 2 feet a day, up to 200 feet tall. Impressive, isn't it? Aren't you glad you don't grow?
You're doing great!
I am a shark. Can you find me?
What does your favorite marine animal eat? Let's find out.
I got sharp teeth, and I like to attack silver-colored fish or divers wearing bright jewelry. What do I eat? You're right. I love amberjacks. You know, they're especially good with a little lemon butter on them.
I'm kind of shy, so I hide among the rocks with just my head poking out until I get hungry. What do I eat? Squid is scrumptious. I'll leave my rocks any time for a good squid.
No, don't touch me. No, I got poisonous spines all over. Don't touch me. Definitely bad to touch me. What do I eat?
Not this time. Not this time. I'm worried about animals with lots of arms.
Oh, kelp is so good. Oh, I grow so fast. I'll never run out. Oh, hand me another piece.
I'm a sponge. My mouth is all over my body. I filter my food out of the water that flows through me. What do I eat? Oh yeah, baby. I definitely prefer plankton.
Grab me and you'll find out why I'm called a surgeon fish. Just like a surgeon, I use sharp blades. Mine are right next to my tail. Do you know what I eat?
Not this time. I'm worried about animals with lots of arms.
Better luck next time. It takes a lot of arms to catch me.
Mollusks better watch out. I'm hungry.
Oops! Careful of me. My mouth is filled with teeth that are up to 2.5 inches long. What do I eat, You know, there's nothing I like better than an elephant seal. Except maybe 2 elephant seals.
One way I protect myself is to change color to match my background. I'm quick, too. It just takes about half a second. What do I eat? Well, if you liked crabs as much as I do, you'd live in the water, too.
I can stick my stomach outside my body to eat. Pretty disgusting, huh? What do I eat? Oh, I eat so much coral that I can actually destroy a reef if I'm not too careful. Oh, I got a tummy.
Keep going. You're just about done.
We humpback whales like to move around.